All right. So big thing to start this one is midterm grades and making sure everybody's up to speed on those. So you got to make sure everything that's been assigned so far in Blackboard and Palo Alto is essentially done before March 12th at midnight if you want to grade for it. Any items that ended up missing by that would get a 0, and then you would still be able to complete them, but I got to put something in the grade book. So this is everything up to March 8th. So last Sunday, which means the stuff due this week is not going to be part of your midterm grade. Yeah, that's just because of the new interim grade thing that they had us roll out for on campus and online. All grades have to be entered in regardless of which direction you're in. I will enter in grades on the 13th, so everything's due the 12th at midnight, essentially this Friday or this Thursday at midnight, with Friday of me entering them in. And then on the syllabus, when we get back from spring break, you guys will be on the skills exam and the final exam. We'll hold class on the 24th to talk about the skills exam. And then you'll get all the remaining class time, meaning that Thursday and the whole next week, to be working on your final exam and your skills exam. Right. Then on April 7th, we'll resume regularly scheduled class for PF Sense, Open Sense, that kind of thing.
Have you figured out if it's going to be in the Blackboard show, if it's going to be on Palo, and you can pull out the last couple modules?
For the final?
Yeah.
The final will end up being on Blackboard, I believe, is where I'll end up moving that. So, and then the skills exam will definitely be through Blackboard. It'll be on NetLab, and you guys will do it there. But we will have that meeting on the 24th to go over the skills exam because there's some nuances with that. And in order to make sure everybody does it the right way, we'll cover it. So don't try to jump into it early or anything like that. If you try to do it early and then say I did it, it won't count because there's a very specific way to do the skills exam. And students that bypass it and don't do it the right way, no, I won't give credit for it because it's a nightmare for me to grade if you don't do it the way that needs to be done. So I've tried that many times now over many semesters and it fails every time. And there'll be a GTA that's going to come in and grade all of your guys' skills exams. So it's important that you guys follow exactly the steps required because that's how he's going to go about grading them. So
is it a singular attempt?
On the skills? No, you guys can run through that until you're done. So when you turn in the file, then you're done.
Okay.
You may schedule that 14 times if you want to get to the file to the state that you want it when you submit it. So in this case, what happens essentially is we'll download the config file and you'll submit the config file to Blackboard.
Okay.
So, but there's nuances with that in the NetLab environment. Okay, so I said I would cover that in the video. We covered that. This week in terms of content, we are covering 13 and 14. So the last two concepts in there. 13 being encrypted traffic. This is probably the quote unquote coolest part of the firewall itself. So we'll run through that real quick. So one of the cool things about a Palo Alto is that even though you're sending SSL traffic over it, SSH, et cetera, the Palo Alto can decrypt all that traffic. You just have to set it up accordingly. So the idea is we can't analyze what we can't see. So if you have somebody on the network that thinks they're encrypting everything end to end, this is going to make sure that it's actually unencrypted when it comes through the network, or we block it entirely if we can't. So obviously there's some importance on SSL and TLS, right? This is the whole idea behind having secure network communication across a shared network. So it's going to encrypt for data privacy, using hash for data integrity, and then using certificates based for authentication. This is how we browse the internet today. Very few websites still interact as HTTP. Almost everything is HTTPS now, right? Which is a good thing, right? We don't want to connect to our bank accounts over HTTP, putting clear text username and passwords everywhere on the internet. That was a thing for a very long time. So on SSL TLS decryption, this is going to help prevent any kind of malware introduction and data exfiltration. That's the reason we want to go and decrypt it. So if we looked over here on the right-hand side, we can see malware and vulnerabilities being introduced, and because they were encrypted, we would allow them on through normally, right? If we decrypt that, we can then detect it. Once we decrypt it, we inspect it, and at that point, we can determine that somebody's trying to exfiltrate data out. So again, exfiltration is all about somebody's attacked your inside network. They're trying to get the data out, think ransomware kind of situation. If they want to get that data out, they're going to do it over an SSL detection because your firewall can't decrypt it, right? They want to be sneaky in the way they're sending data out. In this case, we would be able to decrypt that type of traffic coming through the network. Another reason to decrypt network traffic is most web traffic is therefore encrypted, meaning we can only protect our clients so far, right? So because everything's encrypted, we can't really detect the application if all the content's decrypted. All the niceties we've talked about throughout this entire semester only work if we can look at the traffic. If it's encrypted, we got to do something different. So in this case, we can decrypt any SSL, TLS, inbound and outbound traffic. We can also decrypt any SSH v2 traffic as well. All normal traffic, things like TLS ports, IP addresses, MAC addresses, etc., that all comes through unencrypted. So the way a typical SSL operation works with certificates, which is like you requesting going out to HTTPS websites, we request an SSL connection to whatever server. That server sends us their certificate, which is signed with a public key. The client is going to verify that certificate using an authority. It will then send an encrypted copy of an accession key back out to the SSL server. That server uses the private key to decrypt a copy of that key to send back to the client, and that begins the use of asymmetric encryption. How many of you guys have, I know you have, how many, have you played with SSL certificates? Like on a website or built any out for yourself? It's a pretty good thing to go out and learn. And it's really easy to do. If you build up a simple website and go look at Let's Encrypt to get your own SSL certs, that's a cheap, free, easy way for you to learn that process. But it's pretty important to know, especially in the cyber realm. A couple different ways to do decryption. We have SSL forward proxy, which is outbound, meaning we have an internal user which is going to use the firewall as an SSL proxy to get to the external server, which will then communicate back. The idea behind that is all traffic goes through the firewall, right? So it's going to intercept the traffic, deanalyze, do whatever it needs to, and then send that traffic back out to the user. Now, just because it decrypts the traffic, it does not mean that it's sending it to the internal user as unencrypted traffic. That would be bad too, right? Because then anything on the inside would cause a problem there, right? If somebody already attacked and we're decrypting any background traffic, that would be bad. So we also have SSL inbound inspection, in which case we're not using it as a proxy. And then decryption itself, which is the SSH decryption, this would be for any SSH proxies as well. So if we're doing SSH tunneling or anything like that, this is going to intercept that. Most of the time I spend in a Palo Alto, besides the rules, is in certificates. So I have to go through and monitor and maintain all the certificates in the system, make sure that we don't expire on their expiry dates. If that kind of thing starts to happen, the whole system goes down. It's really, really bad. I can't count how many times that's actually happened to us. We just don't pay attention to it, and then it's a problem. So I built utilities to make sure I never do that again, because it's not a fun day when your certificates expire and you're scrambling everywhere to make it work. So to solve that problem of secure identification using public keys, we're going to use digital certificates. And so a typical PKI component or public key type infrastructure is some kind of root certificate authority as a certificate database. And that one is going to certify any intermediate certificate authorities, which is then going to send certificates or validate any end device certificates where they store that certificate. All right. That end device must keep copies of all the root certificates that are trusted authorities, as well as potentially intermediate certificates as well. So if you were to go look at the certificate database of the Palo Alto, you'll see these in there. If you go look on your Windows device, you'll see them, your Android phone, your Mac, all of those have copies of all the root certificates so that they can go back and do a verification chain. That certificate chain of trust issues again with a root certificate. So these are the issuing certificate authority. They're going to give a valid date range, the certificate authority's IP address, what it's being used for, its public key, a serial number, and a digital signature. That will go out to an intermediate one. Those intermediate ones will be able to do the same thing, but they have to trust and verify back to a root. And then an end device is going to do the same thing where they can issue their own certificate stuff and go back. At the end of the day, the keys to the kingdom fall in these root certificates.
This day Google gets hacked, everybody's screwed.
Well, you got Google, you got, GoDaddy was a certificate. There's so many of these root ones that if you were to go buy an SSL cert, right? Say we don't use Let's Encrypt. An SSL cert is usually a couple $100 to get one, right? If you want a wildcard SSL certificate, you're several $100s in order to get that, if not 1,000 in some cases. So it's extremely expensive because they have to maintain this database and be an authority of it, right?
How many are there out there?
Several.
Okay.
I mean, the last time I looked in the chain, there was tens of root certificate authorities.
Okay.
So I know that doesn't sound like a lot, but that's a lot. And the total number grand scheme, now there's a lot more intermediate certificate authorities out there than there are roots. So sometimes, like if I remember right, GoDaddy in those examples are an intermediate certificate authority, not a root. But you can still get GoDaddy to issue you an SSL cert. They just do it under the guise of coming back to the root authority. So that's where this trust model comes back. Now, when you do your own certificates, you end up with a chain of these particular certificates. And typically you'll have the root, an intermediate, and then you'll have the device certificate. So if you actually go look at a certificate you get from Let's Encrypt, you're going to see 3 distinct chunks in that. Sometimes it's just one and then the root, but with Let's Encrypt, you would see 3 going through.
Who does Let's Encrypt actually go back to as the root?
I would have to go back. I honestly don't know that off the top of my head. Even for as much as I use them, and I used to know, if I broke open the certificate, there again, you'll see all 3 chunks as to who it uses.
So Jason, when
they
you
just changed all their work on that too. Yeah, Jamie?
So when you get a certificate from like DigiCert or something like that, do they, so like the root certificate authority wouldn't really be accessible to us? We would go through an intermediate who then goes through a root for us?
We can do both.
We can do both.
To a root, they're usually more expensive. Intermediates are usually a little less expensive.
Okay.
Because the idea is if a root gets hacked, right, then everything down the chain is affected by that because they're the one that's acting as the digital trust at that point.
Right.
Who is WE1?
And like I said, Let's Encrypt is actually changing their policy. They used to be, 90 days the certificate was good for?
They're going down to 45, I think.
Yeah, they're going back down to 45. Which isn't usually a big deal as long as you have some kind of cron job running or bot or whatever else to do that for you. But that was one of the perks / issues with Let's Encrypt is it generates a SSL cert for you, but it's only valid for 90 days. Now they're going to end up lowering that to 45 days. So you constantly have to go through and renew that in order to make that work. The alternative is you just go buy one. Like he said, you go to DigiCert, you go buy your own SSL cert, and away you go.
They did come out with a new type of cert they're supporting, though. I have no idea what it does, but
I know there's some for there's some other fanciness that you can do within HTTP/ML in the realm of certs. There's a name for it, and the name is escaping me, even though I just talked about it in the briefing this morning. Because we ran into some of those issues. But in the web interface of the Palo Alto, this is what it will look like. You go to device, certificate manages, and certificate. And so we will create a certificate authority on the actual Palo Alto. That's this cert here. That is for us to issue our own certs going down. All right. So we're under device certificates up here at the top. So we are our own signing authority, and then we can put certs underneath of that. Those certs never go out to a fully trusted one. You guys may see these as self-signed certs, right? So if you've ever deployed a service and it always says, hey, this thing is not secure in the way it comes up. A good example of that is in the labs. When you guys go connect to the Palo Alto, you get this is an unsecured website. That it's secured in that it's a self-signed cert, but there's no authority saying that this is real. You actually have to go through the full chain if you want it to be a full cert. The big difference there is whether you have a red padlock in Chrome or your browser or a green padlock, right? At the end of the day, that's ultimately what matters. We will use this interface to generate certificates, view them, modify a certificate use. If we generated certificates out off, say, DigiCert or somewhere else, then we would go ahead and import those certificates down here at the bottom. A good example of that would be when I build out my Global Protect certificates, right? For the ones I use in here. I will often build them on a separate virtual machine that is running SSL or even, OpenSSL to generate the certificates, because I can set those to be very long internally. And then I can import them in here to be used at the firewall level and all the way out for Global Protect or any other services. We can also export certificates. On the export side, where you would do this is on the firewall, we'd be our own certificate authority. Say this is my central main office, then I would generate other device certificates that would go out to my satellite connections. So when I use Global Protect and that kind of stuff, I would generate the certificate on the head end, install it on the other one. So I would do imports on the far side, and that would allow me to have that communication authority right off the bat. Everything's being trusted back to my central Palo Alto. We can delete, and then obviously we can renew those certificates and sometimes revoke those certificates. If some reason something was compromised or an issue, we could revoke it, which basically just means it's no longer valid. When it gets checked against the central authority, it will just say it's no longer valid at that point. And then renew, when we get down to the last couple days, we can go in and actually renew that certificate as well. As far as the hierarchy, you're going to see something like this. So any of them that were issued by this central authority will then be underneath of that central authority, right? So this is one that we create for our firewall, and then all these other ones would be considered device certificates. And we can see that they have their own key here, but they are not a certificate authority on the inside. On that certificate creation, again, on our self-signed certificates, on our firewall, we just generate a certificate with public and private keys. If we are using a certificate authority signed certificate, there's a couple ways to do that. We could, at the certificate authority, for example, DigiCert, Let's Encrypt, whatever else, we can just create the certificate directly with them that has the public and private keys, and we import that into the firewall with all of that key information, et cetera. The other option is we can generate what's called a CSR, or a certificate signing request. This will generate the certificate locally and then send it off for the CA to actually sign it and return it, in which case you'll get a certificate in a file, and we import that into the firewall as a signed certificate. So two different ways to do it. Just depends on your ops and how you go about doing it. Most of what I like to do is the top one. I like to just do it straight from the certificate authority and then import it into the actual firewall. There's a time and a place for doing the CSR if you want to. The key there is whether or not you have to import and actually drag in the public and private keys. So where are you generating those public and private keys? If you want to generate those locally, so those never go out to the internet, then you would want to do this generate CSR side. Because at that point, we own the keys here. We just export this CSR file. The CA signs it and returns it, and all they're doing is giving us a certificate. They are not giving us back the keys. However, if I'm generating this at a CA, in theory, they would have a copy of my certificate and my public and private keys. If they did not get rid of that information, then in theory, it would be on their servers. So two different ways to go about it. To generate that self-signed certificate, we simply come into certificates and add, and then we would give it a name. We need to give it a common name. This is often going to be an IP address or a fully qualified domain name. We will need to mark whether or not this will be a certificate authority. And then we would leave blank on sign by if this is one where we're actually generating our own CA certificate. So you would leave this one empty. And then we would generate this particular one to get a key as well, public-private key, as well as the certificate. Once we did that, we could also import one in, for example, if we were bringing it in from our CA. So you would click on import down at the bottom, go to local, and then you can set up all this information. It asks for you to go to your certificate file. It will then ask for you to either grab your file format for the certificate. Most of it is base 64 encoded PIM. Sometimes you'll get some really fancy super encrypted ones. There's a drop down for you to choose other options. You will also need to import the private key at that point, and then you will point to that file. Now you'll notice this C fake path. And when you click browse and you upload the file, in order for it to come in, it will always say C fake path. All right. Sometimes that trips up students, and that is just obviously we don't want to know where it was on your device. That would be bad too. Okay. And then generally there's a passphrase associated with those certificates in some cases you don't have to, but if you do have one, you got to enter in that passphrase as well. It's good practice to do a password on there. Messages is the way this CSR is set up. The applicant ends up creating the public-private key. Again, this is done at the firewall in this case. Then they will sign that particular request, encrypt it, and send it up to the CA. We send that information along with the public key so they can decrypt it at that point. The CA signs the certificate, sends it back to us, and therefore we're authenticated on that site. The key advantage, again, is that the device is part of the PKI all the way through and actually benefits from the chain of trust. Also, the private key never ends up leaving the device, where if we generate it at the CA, we have to download it, and that private key is being shared around. If you want to generate that CSR, same look and feel as you had up above. The difference is this sign by field, we want to adjust that to say external authority of a CSR. We unmark the block the export of private keys. This would allow us to never get that private key off the firewall. So you have that option to do that. At that point, once you send it off, you will get your export, and it will send that CSR off, and then you can import whatever comes back from them, which is the final certificate. Okay. So the way certificates work is they have to do this chain of trust. So you're going to validate each certificate in the chain. Is it valid? What's the date range? Is it malformed or corrupt in any way? And then we're going to also double check the revocation status of that certificate. If everything works, there's two ways that we can resolve this. There's the OCSP, which is the online certificate status protocol that we use in order to figure this out for the revocation. We also can look at the certificate revocation list, or the CRL. Those are two big databases, so to speak, that double check that. The reason we would revoke is something like a private key got compromised, or maybe a host name or username changed for some reason. A host got decommissioned, like a user left the company and we were doing private user certificates, or a counterfeit key was found out in the wild. Different options of what it can return on status is either current, expired, unknown, or unavailable. So on that certificate revocation checking, the Palo Alto can have that set up to automatically do that, and it will do it on a per session basis. So on the CRL, it will go ahead and click enable, which means we will do a check every 5 seconds to receive that newer version of that list. On the OCSP, we could also do the same check for 5 seconds, and a certificate status timeout is set to 5 seconds, which means if something goes wrong within 5 seconds, we should have the latest data. All right, so how does decryption work on this side? We start over here on the left with our SSL client. This would be like our PC, phone, laptop, whatever else. And that has a trusted root certificate store on it by default. They have some kind of server certificate running. They have a web server running on that device. That will share a common certificate authority out to the firewall. The firewall will take that to the forward trust certificate, which is one that we created on the device. It will then sign that server certificate and send that back to the end user. So it's fully trusted, green in the head bar between the client and the firewall going through there, right? And the reason we can do that is because we take our certificate forward trust and we actually inject that into our trusted store on the device. That's how it knows that it's valid, right? So in other words, we become a full CA and actually be listed in the root certificates on the end device. So when you set up your end devices, you have to inject that certificate into the device. If you don't have it, you get the little red bar across the top that basically makes it look like a self-signed certificate. At that point, if we get a certificate in, it will be able to then go out to the internet and go from any SSL server to send that request out. We give the server certificate, it sends it back to our firewall. The firewall will pass that on through, and then we'll be able to establish that SSL connection through it. So the idea is this is the one that's out on the internet. Our firewall acts as a client of sorts in order to make sure this communication is secure. I guess I'm doing this with my hand and people online can't see. So this is our, for example, google.com, right? The firewall sends a request out to google.com, gets the certificate, stores it on the firewall. We then have a certificate between us and the laptop that says that's secure. Therefore, we redo the certificate that comes through on that information and send it on between here. The idea is because we have this cert, we can then decrypt the traffic, inspect everything going through, then re-encrypt the traffic and send it back out a valid cert connection that we have between the hosts. It's basically a man-in-the-middle attack, right? So if you guys have done any cybersecurity type stuff, we tend to have a man-in-the-middle attack, which allows me to act like you want to send something from your PC to his PC and it has to bounce off the router, right? To know how it gets routed. I act as this MAC address on the particular network. Therefore, both of you are sending me the traffic. I can see it and then send it back out to you. That's if it was unencrypted traffic or even encrypted traffic. I would get copies of that coming through. This is the same way, only with the SSL certificates. All right. So this is just another way of looking at it. That internal user must have that forward trust certificate, the one we generated on the firewall. It will request an SSL connection, sends it out to the firewall. The firewall has a forward untrust certificate. It will then send its SSL connection to the external server, grabbing that server certificate, bringing it into our forward untrust side. At that point, the firewall will sign a copy of that server certificate with our forward trust certificate that we installed over on the server, if it's trusted. If that server certificate comes in and it's untrusted, then the firewall will sign a copy of that server certificate with the forward untrust certificate. So two certificates that we would do, trust and untrust. Basically, it all depends on whether or not this outside server certificate is valid or not. So to configure that forward trust certificate, we go in just like we showed before. We create a new one. And so we always create two, by the way, when we're doing SSL decryption, right? We got to have an untrusted one and a trusted one. This forward trusted one must be a valid CA certificate and trusted by the client, AKA we have to put ourselves on it. And we would set that up as our forward trust one. Untrust looks identical to it other than the fact that it is now this checkbox down below. We would only send untrusted SSL certificate with that signing, which means they would get the red bar when that happens. Make sense? That it's untrusted. When that certificate starts to expire, we need to renew that SSL forward untrust. So we would go into our certificates, click the renew button at the bottom, and we can set the expiration date. By rule of thumb, we don't want to set that to 365 or 3,650, right? Like, why would I want to touch this? Because it's annoying. Why don't I just set it for 10 years and then I don't have to deal with it? Well, if somebody gets a hold of your private key on that certificate, bingo, bango, they have it for 10 years. So yes, it's headache as an admin to always go in and renew these every year, but you kind of want to keep them at least 1 year, sometimes 2 years. A lot of times, some services won't take them if they're set for more than, I think, 3 years. I've ran into that a lot. So a lot of times on internal communication, I'll set that to 10 years. If it's external type stuff at all, we have to end up setting it at 1 to 2 years max. in which case we just have to set it on the calendar that 30 days before it expires, go replace the darn cert. You will be amazed at how much you will forget, and then it'll just keep ticking down, and then pretty soon your certificate stops and all traffic stops because nothing can be trafficked anymore. It's a nightmare. I've done it more times than I care to admit, although I just admitted it on a recording. Oh well. It happens. I mean, I've had the best of luck with a team of 5 people, and we're still going through trying to do it. Because what happens is when you renew that certificate, if you had pushed that out to a bunch of other services, because that's your core as a certificate authority, you have to go replace them on every single device under the hood. So you kind of want to keep your documentation straight of saying, all right, yes, I want to set my certificate authority one on the firewall to say 5 years. That's fine. But every individual certificate, I may only want to issue that for a year, and then I got to keep a chart or track of how those certificates are handed out. A lot of times you'll get it all and you'll be like, yep, we're good. And you forgot about that rogue web server that you stood up for a one-time use case that barely gets a little bit of traffic to it. And next thing you know, you forgot about it and the whole thing goes down. Oh, and by the way, it turned out somebody was not supposed to make that production. It is production and the service is not running. So, on the decryption side, so you go to policies and decryption. We're going to set up a SSL forward proxy policy. We will set it up for service HTTPS and even service 62443. That would be any other SSL traffic that runs on non-standard ports, all right? So if we have other ports in our system that are using non-standard 443, we obviously have to tell them in there if we want to decrypt that. So a good example of this would be 8006. What does that ring a bell for?
Proxmox.
Proxmox, right? It's not running on 443. It's actually running on 8006. If we were to route that 8006 out for whatever reason, we would need to set that service here so that we would decrypt that traffic as it comes through. Let's see here. So we use a rule to find the control. What is decrypted? The phase-in decryption to minimize the user issues, meaning this is where we're going to bring it in. We can see down below, we're going to set this action to actually decrypt if it matches any of this traffic coming in. We would set that as a SSL forward proxy, and we want to make sure our decryption profile is set to outbound traffic. This outbound traffic is something we create. It's a profile. We're going to talk about it here in a minute. And you may want to set that decryption subject to legal or privacy concerns, et cetera. That looks something like this. So that decryption profile over here on the left, we can say what we're going to do with this. On the forward proxy, we're going to end up blocking any sessions with expired certificates, any untrusted issues, unknown certificate statuses. Remember, there's 4 different statuses on a CRL, right? Anybody remember what those were? We should know 2 of them. It's either valid or revoked, right? Those would be the 2 main ones. And then we have unknown and what was the other one? It's like an unreachable, right? We actually couldn't reach the service to figure out whether or not it was valid or not. So this is what you're setting up over here that you're able to actually remove those on this side. Obviously you have other options, so we can go check our block sessions with any unsupported versions or cipher suites. So if we're not allowing certain cipher suites to go through, we just straight up block those traffics coming in. That's a good idea if you are doing government level traffic. In other words, there's SSL, but there's a ton of different cipher suites you can use for that, right? Same way on certificates. You can use AES, you can use RSA, you can use really high-end certificates of, SHA-512 and more going all the way through, make them significantly harder to crack those certificates. But in a really high end, you have to do that. So a good example is TLS version 1.3, right? You'll know in newer versions that they stopped really supporting 1.0 and 1.1. You have to use 1.2, 1.3 kind of things in order to go through. Because they're easy to actually decrypt them and break them now, because they've been out so long that people can do that. All right. So you would want to set a policy as to the minimum version that you're going to allow right here on the decryption. And then the max version, you typically leave that at max. Somebody could use the latest and greatest one to go punch through. Okay. Again, on that review, this SSL server is going to get a certificate imported from our administrator at the firewall side. It will use that local key and send that all the way out. So same setup. SSL request comes in from the outside. We send a certificate back. It creates that SSH or that SSL connection, and we still decrypt and inspect that firewall traffic. I think I missed there. No. Importing our server certificates. So you would click on the import button down at the bottom, in which case you see something like this. So you would bring this into a firewall. You want to do this for any services you're running on your side. So if that device created the certificate, you would import it in, or you may generate it right at the firewall. Now, a lot of times it makes sense to make the firewall the trusted authority. You generate all certificates out of there. On that encryption that we were talking about before, the file format, PIM is probably the most common, but base 64 is pretty easy to decode, right? So you could also do that as a encrypted private key and certificate, in which case you must have the private key and the certificate in order to actually decode it out. Let's see, configure an SSL inspection policy. So that policy is what we had before. We can now see any extra options in there. And that's just us being able to say, here's our certificates that we're allowing through it, that we imported in from stuff on the inside. On the inbound inspection, so we've talked about SSL forward and the other protocols. We can block sessions with unsupported versions and ciphers, just like we did on the SSL forward one. And then on the bottom there, you'll see the default settings allow encrypted traffic if the firewall is too busy. So if our firewall is being hammered at the moment and it can't do decryption, by default, we'll end up allowing that traffic to pass uninspected. Probably maybe a good idea, maybe not. The problem is if you say, nope, don't allow that, then traffic just starts getting dropped. As the firewall becomes overloaded, traffic never passes through. That may be good or bad, whatever your business model is. So what's a place that would be bad?
Allowing it through?
No, blocking it. Blocking it when the firewall becomes too busy.
I hesitate to say credit card companies.
Credit card companies are just finance in general, trading companies, stockbroker exchange, something like that.
Anything extremely time sensitive?
Yeah, everything's time sensitive as when you're going through there. So time sensitive traffic may cause a problem here, but that's by nature, that same traffic also needs to be checked in most regards, right? If it's not being checked, then we just would, in other words, as an attacker, what would I do here?
Just overload the system.
Yeah, you got it. Create a DDoS to the system with a bunch of encrypted traffic. Once the firewall reaches the point of it no longer being able to decrypt it, I can blast whatever traffic through it I want. I guess that's kind of a long way around the way I was trying to get to that point. Let's see. Decrypted inclusion. So we can set specific domains that we do not want to be decrypted. We can even use wildcards up there at the top. So for example, if we want everything under the some domain somewhere, we could put that in there. And this globally disables decryption regardless of our decryption policy. So this may be like a good example up there would be something like WhatsApp or something like that. If we want to keep purely encrypted communications for that particular use case, maybe our business uses that for encrypted communications. We obviously don't ever want to get decrypted out, even at our own firewall. If somebody was be able to compromise the firewall, we could actually decrypt all that traffic.
Would WhatsApp, I guess WhatsApp's entire thing and like some other companies like that, their entire thing is that nobody can read it. Would they allow the firewall to go and decrypt their traffic, or do they even know?
In some cases, they may or may not know that's going through there. Generally, no, because you're kind of a transparent man in the middle. In other words, the firewall is the end client according to whatever the end device is, right? So it thinks it's a phone or it thinks it's a laptop requesting the service and the traffic's getting decrypted. But the firewall's turning around and re-encrypting that traffic back over to the end client itself. Now, you can sometimes catch that decryption, re-encryption, like if something goes goofy or the data's a little mangled, that kind of thing, you could see that kind of stuff coming through. Another one is maybe it's using a really high-end certificate and causing overloading on the firewall kind of thing, right? The harder the encryption of the certificate or the SSL traffic, obviously, the more load it puts on the firewall. One thing I did want to mention here, because it has it over in the end here, and that's pretty important, is SNI. So you would end up having a centralized management for decryption exclusions. Those exclusions prevent the firewall from decrypting specific websites. You can view those predefined ones here. Updates and additions to these predefined exclusion lists are delivered to the firewall in content updates and are enabled by default. You can also create custom ones based on domain names. Domain names are compared against the server name indication, or the SNI, and an SSL client request, or against the common name, or CN, presented to the server certificate. When the host name matches either the SNI or the CN, all traffic originating from or destined for that server is exempt for that. SNI is one of those ways that you can use wildcards or other stuff without having to update it all the time, right? It's a common way to either get around some of this stuff having an issue, but it's also a good way to protect yourself in that issue. So if you're running into certificate issues, go double check your SNI stuff. Okay. Even if the decryption policy is set to no decrypt, the decryption profile can be configured to block sessions with either expired or untrusted certificates. So we could set up a decryption profile, which would just be make sure that we are still blocking expired certificates and untrusted issuers. This is where you guys will need to do some troubleshooting. You'll do this in a lab. So really pay attention in this lab, because there's a lot of setup to decrypting traffic. We would go to our monitor logs and decryption, and we can see where that traffic's coming in and from. So for example, here we can see that it's being sourced from what? This IP address should mean something to you at this point in the class.
Is that our local client?
That's our local client, right? So our local client is trying to go out to these IP addresses. Right? We will see that it's getting decrypted, and here's our algorithms and all this other kind of stuff we'll see in the logs. If we look back at our activity down below, we can see the amount of traffic that's coming in that's SSL and how much of that is being decrypted or not decrypted. Okay. This is important. Like here, we're seeing that, roughly, if we were to look at this, only 1.3 meg of this is decrypted traffic. Otherwise, we're passing 7 gig of non-decrypted traffic. Why? Why are we doing that kind of thing? All right. We can also check these other line charts for SSL activity that gives us in a much smaller window, so we can track what's going on at those points in time. Another reason is to go into our traffic logs, and we can set filters to look for specifically a session end reason is set to a decryption error. And that allows us to find anything that is SSL related type issues of traffic getting through. Another one to look at is the actual inspection glass over there on the left. That will allow us to get and figure out whether or not that particular traffic was actually decrypted as it goes through. Because once it's decrypted, it flows in like regular traffic in the traffic logs. But we will mark this little flag if it was a decrypted traffic flow going through. All right. You may or may not have, go back here. You may or may not have this, not that button. Try again here, come on. This decrypted column by default, you may want to add this column. And you guys have seen that in the labs where it has you adjust and create and show what columns. If you're doing traffic decryption, you may want to add this right in at the beginning. All right. SSH decryption works very similar to that, only it's focusing on SSH tunnel traffics. All right. So whether you're SSHing into a server or if you're using an SSH tunnel to try to pass everything encrypted going out, this is going to decrypt that kind of traffic as well. It works with unsupported SSH key password login accounts. So if you're using, Linux stuff, it will still work. Or I'm sorry, it's unsupported when you're using passwordless login type stuff going through. Uses an automatically generated key to decrypt and encrypt traffic, and all traffic is identified as either SSH or SSH tunnel type traffic. And we'll need to control that traffic using security policies. So an SSH v2 type request comes in from the user to the proxy. That proxy then creates a new SSH request going out to the end server. That response comes back from the server. We encrypt it and send it over to the actual user. So it's essentially creating two SSH sections going through. As far as a session coming in, we would add a rule, something like this. And so we can say any bad SSH traffic, meaning anything that is sourced from this IP address going to the extranet and is SSH traffic, we're going to deny it right off the bat. If it is coming in at all from the user's net, going out to the extranet as an SSH tunnel, kill it. So you played a little bit with SSH tunnels. What would this keep us from doing?
Making a network through the firewall.
Yeah, exactly. It would keep us from preventing some kind of tunnel that just goes straight through the firewall unencrypted as it goes through. And then any good SSH traffic, which is anything that's coming from the user's net going to the extranet of SSH traffic with a service of HTTP or HTTPS, we would allow that. The key here is that we want to specifically block whatever this IP address is. All right. That may be like our web server or our database server. We would never want SSH to originate from inside our network and allow it to go outbound. We're specifically blocking that particular host. Let's see here. Reasons not to configure SSL decryption. When local laws or companies' policy prohibits us doing decryption of that traffic going through, or when a server requires a client certificate and a forward proxy, that would be a problem. No certificate authority, a new certificate authority cannot be added to the client. So sometimes cell phones can be issues with this, or a good example would be a light bulb. Right? Believe it or not, a light bulb has to have those in order for that Wi-Fi connection to go all the way out. They have to have a certificate authority in there. Hopefully, otherwise they're doing it through non-encrypted traffic, right? Bad thing. It may be hard to update the firmware on a light bulb, and therefore we can't get a new certificate authority out to it. What does that mean, though?
It's not connected.
It's just kind of dead.
Yeah, I mean, what it ultimately means is once those certificate authorities certificates expire, the light bulb becomes worthless. We can't update it, therefore it's a worthless product at that point. And you saw a lot of this happen here recently when I forget which certificate authority just renewed their big one. That was a massive deal because when a certificate authority renews, there's everything down the chain that was signed by it. If it can't pull the new ones, you're out. I know that happened on Palo Alto firewalls because Palo Alto themselves was a certificate authority and their certificate for you getting the updates expired. Therefore, temporarily, you had to go out and set, don't check for the certificate authority for updates, which obviously is not cool. I can mimic myself as the update patcher for Palo Alto and give you a bad firmware. But until they could replace those CA certificates and all the Palos, then they said, look, at this point, you either replace it or we don't support it anymore.
And you're just kind of stuck because, especially for clients, like you can't get that through DHCP, can you?
As a new update? No, it has to come through a firmware update, basically. And it's not so much bad with like new light bulbs and stuff like that, but early IoT devices, they never even had the ability to do firmware updates, right? They were, here it is, let it run. And then when there was patches, it was like, oh, we didn't build that into the firmware on how to do updates. Yeah, that was really a thing in the early days of a lot of IoT. And a lot of that is because the logic couldn't fit. The logic to do updates and patch firmware updates and all that kind of stuff, it was flash from the factory, and that's just the way it worked. There was very minimal amount of storage on those devices. You know, the data chips are less than my pinky nail that in order to make that IoT device work. Therefore, it had no logic for firmware updating it. Most of those companies got much, much smarter about doing that in the future. Let's see, the client software requires very specific server certificates. This is something where some service is saying, nope, you either get this certificate from me or we don't allow that traffic to pass, which means it bypasses any kind of decryption stuff like this in a Palo Alto, or if non-standard SSL implementation is being used in some form or fashion, right? So if somebody's using non-SSL stuff that we would expect and we don't have it listed in the firewall, it's not going to get decrypted. All right. We do have the ability to do decryption port mirroring. This was very similar to what we've done with port mirroring in the past with routing and switching. We talked a little bit about this in CyberOps. This allows all exports of decrypted flows out of the dedicated interface on a firewall. Use cases for this are something like data loss prevention or even network forensics. It does require a license for you to be able to do it. And it takes all traffic that comes through there in plain text PCAP files being sent out from the network. All right. Obviously, you don't want that kind of thing to happen unless you absolutely have a reason for that. Let's see. Network packet broker. By the way, this is what law enforcement officers at some point were trying to do across the internet. So back when we had the whole deep packet inspection going on at the ISP level, that was because law enforcement agencies wanted to see what you were trying to encrypt that traffic going across there.
Oh, so this is like, I don't know, my head goes to like the Great Chinese Firewall.
Basically that, 100% the Great Chinese Firewall type thing. Yep. Where you are only allowed certain communication in and out of China, this is how they do that kind of thing. And it's okay because it's a government law there. I mean, morality aside, that's the way they go. Let's see, network packet broker. This is intended to replace the decryption broker. It filters traffic up the chain and identifies non-decrypted traffic. It's just a new tool that allows you to set up your own broker file down below. Right. This is in a newer version. You would be familiar with the old version since you guys are just coming through. There is the ability to use hardware security modules. These are kind of new and go along with the bigger firewalls. It's a physical device designed to safeguard digital keys. It generates, stores, and manages those digital keys and is used by the firewall for SSL, forward proxy, inbound inspection, master and private keys. So if your firewall was compromised, the keys aren't housed on it. The keys are housed on this uber secure device down below. All right, I know that's going to sound like mush. Do the lab and do the lab multiple times. Because there again, this is probably the most complicated setup on a Palo Alto. It's very, very tricky to get it to work. And hint, hint, wink, wink, it may or may not be on the skills exam. So knowing how to set it up is a good thing. Which takes us to some fancy questions. All right, so what two type of activities does SSL TLS decryption by a firewall help to block?
A and C.
Anybody against that? I would agree. A and C. So malware introduction and data exfiltration. True or false, a CRL is consulted first if the OCSP and the CRL are configured on a firewall. In other words, if both are configured on the firewall, which one gets checked first?
What is OCSP again?
That is the certificate authority protocol that goes back and gives you those 4 states of whether it's approved, not approved, etc. I'm going to scroll back here because I don't think we actually talked about which one was first.
This was a long one.
There we go. If both are configured, the CRL is used only if the OSCP responder is unavailable. So what does that mean? It's checking first.
OCSP.
Exactly. Yep. All right. Which type of firewall decryption requires the administrator to import a server certificate and a private key into the firewall?
Forward proxy. Servers. No, because no, because that'd be a public key. Care what the private key is.
We'll come back and look at that one. True or false? The SSL forward untrust certificate should not be trusted by the client, but could still be a certificate authority certificate.
Yes.
Yep. And true or false, the firewall can check for expired or untrusted certificates, even if the SSL traffic is not decrypted.
True.
True, right? And what would we have to do in order to do that?
It was like a no decryption policy.
Exactly. Yep. We would set up a no decryption type policy. Let's make sure we didn't miss those answers. A is true, 4 is true, and D is the one that you were looking for. That was the one I was thinking. It's this inspection decryption traffic. All right. This one's tricky. This is a tricky module with a lot of little sticky points to it. So definitely review it, especially when it comes to the final exam. This is one that you'll want to review and make sure you understand how this stuff works. Mostly because a lot of you haven't really dealt with certificates before. So, and even those of us that have, you have to memorize all the different pieces in here, right? So lots of moving parts. But the lab is really, really good. You'll actually go through and do all these different steps. It'll show you how to import the certificate and put it into Firefox, how to make it trusted within the browsers, that kind of stuff. And then you'll actually do an exclude here on the no decryption rule. All right. Anybody have any questions or concerns going into spring break? On Thursday, we'll cover the logs and reports. And if you missed the very first part of class where I was talking about the syllabus and all that, go back and watch the beginning of this video. Make sure you read that announcement, which is basically just a repeat of the announcement. That all work is due on Thursday at midnight if you want it counted for your midterm grade. If it's not there, I'll put in a 0, but you can still complete the work. But for the purposes of midterm grades, they make sure everything's there. So I've tried different ways to get around that, and they frowned at me for doing so. And I know some people are frustrated they don't have a grade right now, like they don't know what the grade is. It's a two-way street, right? Like if you don't do the homework on time, then I just cut you off on Sundays at midnight, and then you're never able to do the homework. I want you to know the knowledge because this class doesn't hinge around the final exam as much as it hinges around the skills exams. You either know how to do it, not whether you know A, B, C, D.
The skills exam is right before spring break or is after?
Right after spring break. You'll have 2 weeks to work on it. And like I mentioned in the announcement, we'll meet on Tuesday to go over the skills exam. We will not meet the Thursday and the whole next week because you have all that class time to work on that thing. Generally, for most people, when you first go through it, and yes, you'll go through it multiple times if you need to, the fastest you can really get through it is maybe 2 hours. You know, I've seen one student get through in an hour and a half kind of thing. Generally, it would be excessively long. And we'll talk about that on Tuesday. Schedule them really, really long. Go through it. There's a way to save your progress. So if your only way to get halfway through, hopefully you can get to at least the internet zone. But if not, well, there's a way to us to do that. And then you can reload and pick up where you left off. And then at the end, you just submit to me the final configuration file. We'll cover all that. And that's how you'll get graded, is based off that config file. And no, you can't just share config files between people. I can tell the difference because everything's licensed and serial numbered differently. So it's tricky.
Quad code.
Cloud code would have to know all the serial numbers of all the devices in order to pull it off. I suppose you could fake it, but my check is going to be checking against that. Trust me, all the tools you have, I use those tools on a daily basis, as you fully well know.
No, I'm not that stupid.
All right. And it'll be very, very important when we do that skills exam, and I'll repeat that when we go in there, but it has to be done in a very specific way, in a very specific format, because I have a GTA going through and grading those so that you guys get feedback faster so that we can move on to PFSense and OpenSense. Otherwise, it'll bury me for a week or two in order to get all that graded, and we won't get as much PFSense, OpenSense in. So I have a GTA. This is where I would like to use them the most, is grading this stuff. Because what he's going to do is actually take your config file, load up a reservation, load the config file, and then do a checklist of everything to see if it's actually there. And then for each one on the checklist that you miss, that's where you miss your points. Which means if you only get 3/4 of the way through the skills exam, he'll know where you left off and he can do the checks. Okay. That's all I got. We'll see you on Thursday.
And then we're going to talk about it on Tuesday, but is it similar to the labs that we're doing, but without the like extended instructions? Just
yes.
Okay.
Yep. It'll be a high level overview of saying, here's the network scheme. Here's the interfaces you need to configure. Here's all this. I want you to do this decryption policies. You're going to be configuring it like this. Exactly that. Yep.
Just curious,